In this video, I'm going to teach you how to solve problems using the parabola. So I've just written an example up on the board here. A pool company wishes to minimise costs whilst maximising the size of their pools. They decide to restrict the perimeter to 32 metres, and we have to assume that all pools are rectangular, and we're going to find the greatest possible area. Now, this is a problem that needs to be converted into an algebraic formula. So the first thing we need to do is draw a diagram. So we're dealing with rectangular pools, so I'm going to draw a small diagram and define some variables. So obviously I'm going to use P for perimeter, I'm going to use L for the length and W for the width. And I can now formulate a formula for the perimeter, because the perimeter of this rectangle will be twice the width plus twice the length. So 2W plus 2L. Now we've been told in the question that the perimeter is 32 metres. So I can put the formula equal to 32 and I have a formula. Now, usually when I solve something like this, I have one unknown. I've got two unknowns here. So when we have two unknowns, we need two equations. Now the question's also asking about area. So I can write down, using my diagram here, a formula for the area of the rectangle. The area is L times W, or LW. So what I'm going to use is this, and substitute this into this, to then be able to sketch a graph. Hopefully I'll get a parabola, and find out what the maximum is. So let's have a look at this. If I make, let's for argument's sake make W the subject of the formula. So if I'm going to make W the subject of the formula, I'm going to bring the 2L over to give me 32 minus 2L equals 2W. And then finally, I divide by 2. So dividing everything through by 2, it's actually nice and easy, because all of this divides by 2. I get 16 minus L equals W. Now I can substitute this into that, and I actually might write that actually over there. It might make life a little bit easier. Alright, so let's write it over here. So I've got area equals LW, and let's substitute that W in. So I've got A equals L multiplied by 16 minus L. Could expand that. Don't have to, but I will do. That tells me it's 16L minus L squared. Now looking at that, I can see that's a negative quadratic. So if I'm going to sketch it, it's going to be an unhappy face, a negative face. So if we're going to sketch something like this to be able to solve the problem, we have to go through certain things. We need to find the turning point, we need the x-intercepts, and we need the y-intercepts. So let's do that. So let's begin with the turning point first of all. So just a reminder that when it's in general form, so this quadratic's in general form, we use the formula minus b over 2a, where b is the coefficient of the L, and a is the coefficient of the L squared, or in this case. So x will be minus 16 over 2 multiplied by minus 1. So x is minus 16 over minus 2, which is 8. So that tells me that my turning point's occurring when the line is x equals 8. Now x in this case is L. Okay, so when I plot the graph, I'm going to be plotting A against L. So technically L equals 8 meters. So let's find the y value when x is 8. So in other words, I'm finding the A. So let's do that by substituting into this formula. So A equals 16 times 8 minus 8 squared. And I'll do that. I end up getting 64 meters squared. So my turning point is occurring when the coordinate is 864. Alright, let's go over to the x-intercept. So that occurs when y equals 0. So let's go into this. Remember, y equals 0, that's our A. So I've got 0 equals 16L minus L squared. Now it's in general form, so we need to factorise. However, there is no plus C, so we're not going to use factorising with two brackets. We're going to use factorising with just one bracket. So I can pull out the common factor L, and I get 16 minus L. Now I'm going to use the null factor law to solve this. So either L equals 0, or 16 minus L equals 0. So moving that one over, 16 equals L. So either L equals 0 or L equals 16. So they will form my two roots on the graph. And the final thing I need to find is the y-intercept. The y-intercept is found when x equals 0. So having a look at that, That's going to be when L equals 0. Okay, so subbing that in, I end up getting 0 to minus 0, so I end up getting that the y-intercept is 0. So let's sketch it over here. So remember when we're sketching, I'm only dealing with positives because we don't have negative areas, and I've got my negative quadratic, like so. Turning point, so this is my A, this is L. The turning point's happening at 8, 64. And 0 and 16 are my x-intercepts. So we can see here that the maximum area occurs at when the length is 8, the area gives us 64, but also let's remind ourselves what was the formula for the length. We had W equals, remind myself what it was, 2 seconds, it was W equals 16 minus L. So W equals 16 minus 8. So W equals 8. So what we're saying is the maximum area is occurring when the length is 8 and when the width is 8, meaning that it's a square.